Hi everybody, I'm back, and I don't sound disgusting. That's always a plus. So today we're going to do our last day of notes for solving systems of equations. We are going to use elimination. Just so you're aware, sometimes it's called linear combinations. It means same thing though. So let's go ahead and find out what it does, shall we? Yes, let's do it. So elimination, I got your notes right in front of me to make sure everything matches up properly. Elimination just means that we're combining equations, so we're going to add them together, and our goal is to eliminate a variable, and then we just solve for the remaining one, okay? So, remember, if you need more time, pause the video. This looks very wordy, probably because it is. So, I'm just going to go ahead and read through it. If I scroll and you need more time, rewind the video or pause the video, okay? But 5 steps, easy pie. So number 1 is arrange the equations in the system so the like terms line up with each other. So you want the x's on top of each other, the y's, and then the constant. A really good way to look at it is if you just want to put them all in standard form, like that had the x and y, x plus y equals m, or not m, ax plus by equals c, that's standard form, and just have it line up like that. Doesn't need to be in that form, but that's an easy way to help you remember how to make it look. Okay? Step 2 is multiply one or both equations so that one of the variables, either the x or the y, doesn't matter which, have opposite coefficients. So same number but different signs in the equations. Step 3, you go ahead and combine them by adding and then solve for the remaining variable, because when you combine them, one of the variables will cancel each other out because of the opposite signs. So you'll only be left with the other variable, which then you could solve for. Once you have that value for that variable, you take it, you plug it back in to one of the original ones, and find the value for the other variable. And then step 5 is to check your solution. So just plug it back into the equations and make sure it works for both equations. Or you can go ahead and check it in the calculator if you want. It's up to you. I said I wasn't gross, but now look at me, all gross. Okay, so now we're going to go ahead and solve a system by using elimination. So step 1 was to get them in the same format, so either like x's on top of x's, y's on top of y's, and numbers on top of numbers. We got the numbers on top of numbers, but the x's and y's and the equal sign, which we also want lined up, is still a little funky. So what I'm actually going to do is I'm going to go ahead and leave the x and y here because that looks like standard form. I told you that's the way I like to do it. Doesn't mean you have to, but I'm going to keep the first one as is. And I'm going to change the second one to look like this. So this one, it's got the x on the other side of the equal sign and in front. So I'm just going to subtract 5x from both sides and put it in the front. So now I have 4x minus y equals 6, same as how I started. And now I can have negative 5x plus y equals negative 9. So the numbers line up, the equal signs line up, the y's and the x's all line up. So it's great. The next thing I want to do is try to have either multiply one or both so I get opposite coefficients. Now, luckily, I don't actually have to do this because one of these variables already has opposite coefficients. So this one has 4 and 5. It's different signs, which is good, but not the same number. Now, the y's do have the same number, and they have opposite signs. So these are actually opposite coefficients, meaning that when I add them together, the y's will cancel each other out. So I go ahead and add it together. 4x plus negative 5y gives me negative 1x. Negative 1y plus 1y gives me no y's. It's gone. And 6 plus negative 9 gives me negative 3. So now I'm only left with one variable. I can go ahead and solve. So I divide both sides by negative 1. I end up getting x equals 3. So that's half of my equation. Now that I have this, I can plug it back in to one of these two and find what y is. So I'm going to decide to plug this x value in for the second one because it's already solved for y. Only because it's a little bit easier. You can go ahead and plug it into either. It's totally fine. So I plugged it into the second one. So I get y equals 5 times 3 equals negative 9. Multiplied it together, you get 15. 15 minus 9 is 6. So I have x equals 3 and y equals 6. So that means my solution is 3, 6. Okay? Don't forget to check it. So you can either do this in the calculator and graph the two, or you can go ahead and just plug it in. So 3 times 4 gives me 12, minus 6 will give me 6, and 6 is equal to 5 times 3, which is 15 minus 9. So it works. Okay? So next one, did I do another example with you? Yeah. So this one we're going to do the same thing. So we have y equals x minus 3 and y equals negative 3x plus 4. What's really nice is that the y's are on top of each other, equal sign, x, number, it's all good. Okay? So now I want to look for opposite coefficients. The y's have the same number, but they have the same number, but also the same sign. So they're not opposites. The x has a 1 and a negative 3, so not opposite coefficients. So that doesn't help me. So now I need to multiply one or both of these equations, so I can manipulate it enough just by multiplying, so I can get opposite coefficients. I'm actually going to decide then, when I have to multiply, which variable you want to cancel out. Okay? I'm going to choose to cancel out the x's. So I need these two x's to have opposite coefficients. So this one has a negative 3, and this one has a 1. The easiest one to change is the 1, because I could just multiply that. And the opposite of negative 3 would be 3. So I need to change this 1 to a 3. I multiply it all by 3. So when I want to change this to a 3, I have to multiply everything in that first equation by 3. Okay? Excuse me. So 3 gets multiplied by y, 3 gets multiplied by x, 3 gets multiplied by negative 3. So it comes out to be 3y plus 3x minus 9. This is the same meaning, it's just not simplified. So I unsimplified it, basically. So I could have opposite coefficients here in the x's. So because I have these opposite coefficients, I can go ahead and add these two equations, and these x's should cancel out. So I go ahead and add 3y plus y gives me 4y. 3x plus negative 3x gives me 0, so nothing. And 9 plus 4 gives me negative 5. So that's what I'm left with. This is the only variable. I can go ahead and solve for it just by dividing both sides by 4. I get y equals negative 5/4. Ugly number. Doesn't mean I'm wrong, though. Okay? So I take that number, I plug it back into one of these two equations. I'm going to plug it into the top one just because I don't have to multiply anything with the x. So I plug that in. So I get negative 5/4 equals x minus 3. I add 3 to both sides. So I get x equals 7/4. So my solution would then be 7/4 comma negative 5/4. I can easily check this by just plugging stuff in. I'm going to want to use my calculator for it. Or I could graph it since they're already y equals. And then I would use second trace and go to intersect to find the solution rather than the table, because they're decimals or fractions, whatever you want to call them. Okay? And that's how I can check my solution. Now you are going to try this one on your own, okay, and see how you do. Okay, you can either pause the video or wait until the end, but this is just like before, so you're going to have to multiply maybe one or the other. Okay? We're going to move on to example 3, though. So example 3, we're going to still do the same thing, multiply by elimination. So x's, y's, numbers all on top of each other. Cool. Do I have any opposite coefficients? So I have a 5 and a negative 6. No. I have a 3 and a negative 2. No. So I need them to be the same. So I'm looking at my numbers. To get a number that's I can multiply both 5 and 6 by, that makes it the same number, that's going to be a lot, because I need them both to be 30, and that's a big number. Where 2 and 3, though, if I multiply them, I can get a 6 out of them. So that, I'm actually going to eliminate the y. So I'm going to multiply this side by 2, because I want to make this into a positive 6. And I'm going to multiply the second one by 3 to make this into a negative 6. That way they'd be opposite coefficients. So everything gets multiplied. 5x times 2 gives me 10x. 3y times 2 gives me 6y, and 5 times 2 gives me 10. And do the same thing on the bottom, so I get negative 18x minus 6y equals negative 66. So the y's now have opposite coefficients, which means when I add them, they're going to disappear. So 10x minus 18x gives me negative 8, 6y minus 6y gives me 0, and 10 plus negative 66 gives me negative 56. Divide everything by negative 8, I get x equals 7. Take that value, just like with substitution, I take that and I plug it back into the original. So I'm going to choose this top one and solve for the other variable. So 5 times y gives me 35, and then I subtract 35 from both sides. So I get 3y equals negative 30, divide by 3, I end up getting y equals negative 10. So my solution is 7 comma negative 10. Okay? And then this one is your own try on your own. So, try those two on your own. If you have any questions, we will go over it for sure. Okay? Remember, you have a quiz on substitution next week, or next class. Okay? So, and we will practice elimination, so don't worry. But other than that, I will see you later, okay? Bye!